Welcome to another Reactor stream. It's Chris with Click Team. We left last week working on a level streamer so that you could have a level with limited object count. So we're going to work on that some more today. Let me quit listening to myself. So hello again. First thing I want to go over is the new items for the Reactor have been posted. This month you can get access to the Beat 'em Up engine, the in-app purchases object for Android, and the Shoot 'em Up engine, which is pretty cool. The two engines are really cool. Jason Orm came out with this one just recently. It's a pretty excellent little Beat 'em Up engine. Get a little sample here. Get your final fight on. Turtles, arcade, whatever else you kind of want to make. It's a pretty good job. So that's included. $20 value. The Amazon in-app purchase, so if you ever wanted to try to exploit the Amazon market with your Android application, you can do in-app purchases. And then the Shoot 'em Up engine, pretty little simple configurable engine by the creator of Dark Devotion. Allows you to create your own shooter. Highly customizable, pretty cool. So those are all free. In addition to that, Perry, one of our longtime users and a Reactor member, for free included his ultimate package image resizer and guides, which is pretty cool. So yeah, if you're a Reactor member, go get those things now. And if not, sign up and you can grab them at the end of the month. So excellent. And the patron is right here at patron.com/clickteam. So on to what we were working on. So we left off with the level editor last week, which I did a little more hacking and I came up with this. So here's a world I've created, and we can see what it kind of looks like. In fact, let's take a picture of it so that we keep it stored so we can compare. And so this is an array-based level now. So we load the level via the array, doing columns and rows. And in this case, we launch the columns and rows when we load the data by on-group activation. We set the array file that we're using, and then we don't need that test string anymore. We load the number of columns by the X dimension, and then on each column load we run level load by the dimension of Y. So no matter how big the array is, it will automatically sense it by pulling down that expression. And then what we do is on each load level row right here, we compare value at XY. Is it in a loop index load level column? And then in the embedded loop, we have load levels row, which will give us an XY coordinate on the array. And we ask if it's 1, because I'm only dealing with one image right now. But you could have, down here, this is 1, but this could also be 2, 3, 4, 5, whatever. But just for the simplicity of it, working on it today, we just have the one tile type. You don't want it to be 0. So in the previous level editor, we had it set to 0 in the list object, a 0-based numbering system. The problem with that is when dealing with a numeric array, if it's null, nothing in the cell, it's going to return 0. So if you set a brick type to 0, then it's going to create those bricks all the time, anytime there's null space. And you only want to pick up the bricks that you actually laid down. So we changed it to 1. Loading is, that's loading, and then saving is pretty much similar to what it was before. I first make sure that I destroy any objects that are outside of the area, the map area, which that would be these bad boys up here. We don't want specifically this one, we don't want it showing up. And they're set to a group. So those get deleted automatically. So my mouse is dying on me. It's been a pain all day. There we go. And then we on group activation again. This was held over for the list level saving. And what we do here is we start loop, save level, number of objects times. So when we execute this fast loop, it pauses the main loop and then executes this item. So it picks one of the group objects that's in the play area, and then we don't need that anymore. It writes the tile number value to X divided by 32 because it's a 32-bit grid, and the array works in a cell system that's you know, 0, 1, 2, 3, 4, 5, and the objects are spread apart by 32-bit distances. So in doing so, you know, up here at the very corner would be 0, 0, 1, 0, 4, 0, 3, 5, 0, and that's, you know, 5, 1 for x, y, and so forth and so on, when it's really 5 times 32 over and 2 times 32 down. So we have to convert it back down, and that's why we divide the x and y positions by 32. So that gives us the relationship of each cell in our array is one 32-bit grid spot on the map. And that gives us this glorious map. So that's pretty cool. Now it's on to the level streaming. And I kind of had a eureka moment earlier today. Oh yeah, so Danny, in saying there is no simple solution on zooming in and zooming out unless you're using HTML5. I don't have a simple solution. I think we talked last week about the concrete jungle example. I still have to dig that up, so I promise to do that. Anyways, back to what we're doing. And I will remember to do that in a future stream. And while I have you here, while I'm looking at comments, let's see if anybody on YouTube has a question real quick. We don't want to forget anybody. And let's see here. Oh, so Mr. Jones wants us to play the Yay Fenny trailer. Maybe I'll play it at the end of the stream. A little too late to play it right now. All right. So, Danny, how is Yay Fenny going? Have you broke 1,000 sales yet? It's a great question. Have you broken 1,000 sales? Selling games out there, especially on Steam, is a tough marketplace. So I know what you're going through. Keep it up. Good luck. Okay, so now I'm building the actual streaming. So what we're going to do real quick is we're going to cut off these two groups, which means that when this group activates, which is very similar, if you look at it, it's very similar to the same code that we used to load the level in the previous stream, in the previous application, the editor. So if I run it, you'll see that I get the world that, you know, we're trying to create. So there's our walls, there's our rooms, just kind of like we had shown in the snapshot here. So for instance, that right there is this section here. Now the reason why I made the window so small is because we're streaming the level in. I wanted to use extremes to make sure that we show the streaming. So as it stands right now, we're creating all 755 of our tiles. It's a lot of tiles. So the first thing we have to do is we've got to remove the out-of-bound pieces. So we're going to activate this group again and we'll look at it. And what this says is if X position of our box is lower than the left bounds or greater than the right bounds, and if the Y position is less than the top bound or greater than the bottom bound, then we go ahead and delete them, destroy them. Now I'm setting the bounds here. So what we have here is left visible edge and top visible edge. So when we're running the app, which I'm going to do again, right up here, we're talking about this corner here. So if we look at the debugger, okay, as I move down, you'll see that that corner is consistently changing. However, it's changing 12, 12, 13, 14. It's not the actual pixel position. It's divided by 32 because that represents the cell. So right up here would be the first cell. Now it's on the second cell on the first row. So that's important because we use that as reference to access the array. And that's why in there you see that I am dividing it by 32. Now in our borders, what I've done is I've found the center of the screen, and this is based on whatever the frame width is, the window right here, the window size. We divide it, we get the X right frame and divide it by half of the frame window width. That gives us the middle point at any point. And then we then subtract 320. So that would put it about 160 pixels left of the left visible edge. And then same thing here for the right visible edge, it puts it 320 pixels right of the visible edge. And then we do the same thing with the bottom and the top. And what happens is if you look at our numbers again when we run it in the debugger, you'll see that I'm getting these borders that are basically out here around our window, right? And so if anything is past that, it gets destroyed. Let's test it now. So you'll see that we have a cutoff here. Anything that was created before that, after that, is gone. And in fact, some of this is probably deleted now too. As you can see, the buffer is working, erasing anything that goes outside of our visible, our border. So anything past this kind of squarish area, and I think it's important to illustrate this correctly. So we'll just grab a new image. Basically, what we're trying to do, new paste is, let's take this. In fact, let's just take out this. Edit, copy, edit, paste, wonderful. And then we're going to say there's the inclusion zone. So we have this inclusion zone. And then outside of the inclusion zone, we have the removal zone. So what we're doing is we're using this green zone here that's outside of the visible viewport of your game to where we hold objects in memory and where we stream them in. If they end up in the red zone outside of, as we scroll along in the world, then we delete them. So with that hopefully somewhat simple explanation, let's activate the streaming. So right before we started the stream today, I had a eureka moment where I got streaming to the right to work. So if we take a look, as I'm moving, it's popping in the world. But if you look at my object count, I'm still around 33 as I go through the world. And of course, now I've run out of objects because the array is past the expense, and I'm only going to the right. So again, that's what the level looks like, and we stream through. Now you saw me populate some information in the list box. I want to go ahead and let's remove the scrolling on that. So nothing's being fed into the list box currently, right? And that's because I'm using that to test where the position of my objects are going. So essentially what's happening here is we have this event here, event 20, where I'm checking the character. Is the character moving faster than 0? If so, run the stream loop. And every one time the stream loops, we run stream right 14 times, which means I sense for stream right basically writes objects to wherever this is positionally on the board. And we do that, goodbye. So we do that by starting at 14 times. In the size dimensions of our screen, we can fit we can fit 10. Be nice if the color was right. We can fit in 10 32 pixel sprites or actives on the vertical. So that would be for the up and down. Thank you. That would be for, I really need to fix that. Transform, rotate, counterclockwise. black, and duplicate, and flip. There we go. So we can fit 10 32 by 32-bit pixels here. But we want to also get the overage in the green zone here. We want to also get the overage. So we add 2, a total of 4, because you see that we run that loop. Oh man. We run that loop 14 times. So we have this object called placer, where we set the X position of the placer to the left visible edge plus 14. So if you remember when we're running our app, we're talking about left visible edge. So as I move forward, I add to that left visible edge because I'm changing right here, whatever this corner is, right? So we're actually 6 by 32, so 6 by 32, so that's what? Who's a math head? Oh, see, this mouse is just horrible. So that's 192. So the actual X position of this corner is 192. So divided by 32, that gives it 6. And that's why in the code, we add that 14. And the reason we do that is because that's going to push it from here to here. Okay? And then we do the same thing with the Y when we run the loop. Stream right, and then by Y, because it's going to run 14 times down, the Y is top bounds buffer minus 32 divided by 32, which gets whatever that Y position is up on a 32 grid. And then we add the loop index plus 32 so that it goes down. So that positions the placer, and then this is where we write that debug information. And then the next event tests whether or not it's overlapping a sprite already, because we don't want to keep writing sprites over and over and over again. If there's data already there, if there's a sprite already in the slot, in the array slot on the grid where it should be, we don't want to create another one. You only want one per grid. So that's checks to make sure that there's no overlap. If there is no overlap, then we ping the array to ask if that array spot equals 1. If it does, then we create that object, and I just was putting this in here for debugging. And then what this does right here is, as you're moving along, sometimes things can get out of joint when you're moving because of how Fusion loops. So this associates, because you're only going to be off a pixel, it snaps it back into that 32-bit spot. And the result is we get the ability to stream. And then if we look at our debug data, you can see that the first time it ran at for X, it ran at 448. And then if you add 32 to it, you get 480, and it ran the 480s, and it just runs all of them. But if we look at our object count, we're only at 50 objects, which is great. So now we have to try to do, I want to try to do down next. Let's see if there's any questions at this point. Right, so Dan Insane, yeah, the way it was done on Concrete Jungle was a lot of math, a lot of positioning. I'll look up the code and we'll show it, but I'm just warning you up front now, it's not going to be a click here and zoom in and zoom out solution. That's something I would like to see in Fusion 3 myself, because that's something a lot of people would like to use. I'd be great for games like Concrete Jungle or zooming out to a map. I've done it in one of my own games, but my method isn't as nearly as solid as the Concrete Jungle version, and I'd rather show you that one. No, I mean, you saw it in Concrete Jungle. It works. So, you know, if it works, then you can do it. If you can do it, you can do it. Just a matter of sharing the code. Okay, so now I'm going to try to do streaming from the bottom, which means that as I move vertically, as the character moves down, I want to stream in this area. So we want to be able to grab this, color, yellow. We're now going to try to stream in. Oh, come on. Photoshop. Now we're going to try to stream in this part. Down here. So, let's get started with that. Okay. So, now we got to kind of tilt everything onto the side. So the first thing we're going to do is we need to create the fast loop. We'll call it stream bottom. Wonderful. And it's not going to be 14 loops. It's going to be a little bit more. So we've got a resolution of 320, and if we divide that by 32, that means it's 10 wide. And for some reason, that doesn't make sense. 2. All right, well, maybe we can get away with it being 14. It shouldn't be. It should be more. But we'll do it anyways. So stream bottom 14. Just had a message hit me. Let's see what that is. Okay. Okay, so now we're going to need to position the object. Stream in bottom border. Bottom. Okay. Oh man, this mouse is killing me, man. It's just killing me today. And then we'll change that. So now the X position has to be here, but -2. So, easy enough to do. We can take the same formula, drop it here, but instead of +14, we'll say -2. Now the problem is this is the one that we're going to iterate through. We're going to iterate through X. So Y is the one that we have to make sure is set consistently. So the Y position is not going to be static. It's not going to iterate like we are up here. It's going to be static. This one will iterate because we're going to move this way along X instead of down on Y like we did with stream right. So to do that, we need to set that Y position. And if we look at our grid, our Y position can go down. So our screen size is 240. Now if I divide it by 32, I'm going to get an uneven number. I'm going to get a float, 7.5, so we'll just round it to 8. So 32 times 8 is 256, right? And then we could say we'll add 10 to it, which means that we will say value bottom bounds buffer Y, and then we'll say, nope, doing it wrong. We're going to say value top visible edge plus. We said it's 8, but we wanted to make it 10. I'm going to go with 9. Kind of seat of my pants business there. So I need one more open brackets, because then I got to multiply this by 32. I close the bracket, and then it's going to be plus stream bottom. So the first time it loops, it'll set it here because this returns 0, and then 1, 2, 3 as it adds along. So the Y position now is set. Of course, that's the wrong place to iterate, because we iterate on the X, which is here. So we close this. And then we add 2 plus signs is no good. Okay, so that should give us what we need. I'm going to move that off because we may have to do some testing in a minute. And then we'll still need this code here. Use the same loop configuration. And then we've got to fix this. So it's left visible edge plus 14. It's actually left visible edge minus, that's left visible edge, yeah, minus 2. Minus 2. I think I'm doing that right. Yep. Okay, and then, because that gives us the x, but then we have to go ahead and add our loop index into that. That should cover that. And then our top visible edge plus 9. So this part iterates horizontally, and this brings us down to the point that we need to be vertically. All right, so if that equals 1, then we'll create the object, and we're good to go. And then we'll run the realignment routine. So let's run it and see if I've broke it. Well, so far so good. That's it. That's it. We can confirm it by going here and running our level editor again. And if we scroll down, we've got 1, 2, because we'd only see about this much. The computer seemed to have froze. Oh, it's created on a different layer. That's the problem. Okay, so we know the data's there because I looked at it earlier. So we know that part's working. So we're now streaming in this direction, in this direction. Now we have 2 directions left to do. Any questions so far at this point? Is it am I making any sense? Is it kung fu? Let me know what you guys think. Well, you know, Danny, concerning your question about math, or comment rather, I wouldn't think that you should let yourself be hindered with math. Fusion is actually great at helping you learn math and learn programming in general. In fact, the two primary guys working on Fusion 3 currently, Anders and James, both got their start in programming using an older version of Fusion. And it helped accelerate their learning process. James, if I'm not mistaken, James was once asked Francois if he could make him an object that he needed because he identified a function that was missing in Fusion. And Francois, you know, said, no, I will not do this for you. And James was like, taken aback. What do you mean you won't do it for him? He's like, you know how to program. You've been using Fusion for a while. Here's a SDK, and here's how to use C and figure it out. And that's what got him started. So don't count yourself short. It's just math. I mean, computers only do adding, subtracting, multiplying, and dividing, and everything can be broken down to that. So just keep that in mind. Okay, so Jeff, you don't understand how the different objects get selected in the loop to be placed in the frame. Okay, great. So I'll try explaining it one more time to make sure that we understand. So our character is moving in the frame, and the frame is, you know, huge, right? So the frame itself is way huge, right? But we only see this much of it at any one point, right? And I'm centering the character. Where am I centering him? Right here. He's always center of the screen. So we're sliding the world around this huge frame, okay? As we slide him, we're keeping track of these variables. We're keeping track of the left visible edge and the top visible edge, which in the game, at any point while it's sliding around, is this point right here. It's this corner point, okay? And then what we're doing is we're calculating boundaries, barriers, right? And we're doing left, right, top, and bottom, and that represents on our image here, this point here. So that would be the left boundary, this is the right boundary, this is the top boundary, and this is the bottom boundary. So the very first thing we do is, based on those calculations, based on those numbers, we ask if one of our objects, one of our tiles, is outside. If the tile is outside here, which is done through the comparisons that you see here, these comparisons, if it's outside that boundary in the red zone, we then destroy it. So if it ends up being out here, we destroy it. So stuff in the green zone stays good. It'll stay in active memory. It will not be erased. Now the yellow bars represent the two areas where we're actually adding in level data. Okay, so we have the array, and the array functioning as a grid has data in it, and the grid, you know, 0 to whatever and down 0 to whatever. It's actually one base, so 1 to whatever and 1 down to whatever. We store 1 if there's one of these sprites in that slot. And then by multiplying those two values, its XY position in the cell, by 32, we're able to expand it out onto our grid. So as we're moving through the board, which happens down here, whenever the speed of my character is greater than 0, in other words, he's moving, I'm then streaming. I'm running a fast loop called stream. I run it once. And the reason I'm running it once is because I have to run embedded in it 4 separate fast loops X number of times. So far we've chosen 14. And we've done right and bottom. So what happens is when stream right happens, because it's running 14 times, the very first time that runs, it sets this particular object right up here. In each of those 14 loops, it moves it down 32 pixels till it reaches the bottom. So as it's moving, it's jumping 32 pixels on the grid. So because wherever it's positioned, it's always going to snap into that 32-bit position, 32 by 32 pixel position. And then it detects to see if it's overlapping. If it's overlapping a sprite already, meaning that we already accounted for that cell and we're already writing a sprite in that cell. We already have one there. And if so, ignore. We don't want to write another one. You don't want 2 overlap. You just want 1. And if that's true on this multi-conditional line, then the next condition is to check to see if that cell in the array actually has a sprite for it. In this case, sprite equals 1. So if it does have a sprite, so it's 1, then we create that sprite on top of where the placer is. And then you can ignore that. We don't need that. And then the next line here, what this does is, in case it's offset as I'm moving, then this snaps it back into its 32 by 32 position. I also thought about embedding the actual XY data into the object itself, and then you could read that as well. And I may try that as I stress test it over the week before posting you the code. And then the same process for the bottom, except on the bottom, instead of iterating vertically down, we're iterating horizontally. So in our diagram, we start here, and then we read as we move along here. And because it's done on a fast loop, theoretically, loop-wise, the main loop's paused. Everything's paused. So it moves characters, it does all the movements, all the internal stuff. It gets this point, it pauses the main loop, and then it runs this fast loop, doing this checking process. And that's how it's streaming out the levels. So I don't know if I just did more Chinese to you, but Jeff, does that answer the question? Okay, so you just said in the array is the position data that it got from the level editor. Where in the loop does it know which tile object to create? Okay, great. So currently on 24 and 28 on the streaming code, we're detecting, again, is it overlapping a sprite already for this particular cell in the array in its association 32 by 32 on the grid. And if there is no array, if there is no tile there, then the next line, this line right here, asks if the array is storing in that associated grid spot the value 1, because right now I just have I'm storing ones or nulls, right? And remember, with a value-based array, I'm going to, whenever I ping a cell, if there's no value in there, I've not written anything to that cell, it will return a 0. So we can't use 0 as a tile tag when using a value-based array. So it has to be positive numbers. You could do negative numbers too, but it can't be 0, because null will always return 0, meaning you would draw objects everywhere. In fact, for giggles, let's test it. I'm going to put 0 there, and we'll run it. And you'll see that I'm just going to create a wall, except where it is actually 1. See, it's inverted. So that's kind of cool. So we go back to 1. So does that answer the question, Jeff? While Jeff's letting me know if I've answered it, I'm going to check the other side. YouTube, no questions yet. Feel free to ask questions, guys. I'll try to answer them. Okay, so while we're doing waiting for Jeff's response, see if he understands what we're doing, I'm going to now try to do left, going reverse. So I'm going to copy stream in right, rename it, stream in left. Oops. Okay. And then we need to change this to left. Really? Okay. And then we need to do up here, copy, stream left, 14. Okay, so in the case of left, we now need to position our tile here. Our tile placer now needs to be put up here and gone down vertically, which we're really close to doing that already with the code. And all I have to do now is, instead of +14 for left visible edge, we need to do, I guess, minus, and I said 14, so -4 maybe? And I think, and here, we got to change that to -14, -4 rather, if I'm doing it right. And that remains the same. We do have to change the loop index label here. It's this mouse. It's murder. Murder. Yay. I did it. Okay. We'll do it here. Great. Super. And let's gamble and see if it works. So we're streaming this way. And we're streaming back. Look at that. This is one of those moments where you're programming, you're like, I'm a god. So our object count is nowhere over 50. And we started by displaying 775 different objects, full map. And now we're floating around 40. And I'm not seeing much of a performance issue. Now we have to scale it up to see, how it works with big levels. But that's pretty cool. All right, so what's left? We got to go down, stream down. Or stream, it's actually stream in up. Because we are streaming down, I think, already, right? Let me deactivate that. And we'll go down too. Yep. We're streaming in the down stuff. Okay, cool. Okay, so you understand now? Okay, good. And yeah, Chinese, hard language, isn't it? We try to make the event editor as easy as possible, but yeah, sometimes it can be a little wieldy. But I think we're doing pretty good. All right. Alrighty, so this is now going to be stream top. And we're going to do this biz. And then up here, we need that bottom. Swap. What in the blessed earth? And then top. 14. What the heck? Who cares? All right, so now we're doing the top, which means we're going to try to stream in this bit of information. Excellent. Okay, so to do that, we are declaring on our fast loop top 14 times. We now need to find this location here, which is very similar to this location, only it's the reverse direction. So let's take a look. We plus 9, so if it's 8, we really want 1 extra. So we should theoretically be able to do -1. To be safe, I'm going to do -2. Call me a gambler, if you must. -2. And create set direction. We don't need that. Get that biz out of here. Get that out of here. We don't need it there. Okay. And we now need to correct our. Hey, look! I found a bug that for some reason wasn't triggering. See right here? That should be stream bottom. So let's go ahead and fix that. And I'll just do it manually. I wonder if that's going to affect it working. So 2 tasks. We'll deactivate what we're working on. And let's see if bottom still works. Yeah, it's still working. Good. It's actually working better than it was before. Okay, good. So back to streaming up. Activates. Replace the bottoms with top. Top. And I think we're good. Let's give it a shot. So we're going down. And we're going back up. There it is. I'm going to be honest with you, I didn't think I was going to be able to pull this off. There may be some bugs still. We'll figure it out, but it seems to be working pretty good. Let's widen the view by removing this. And let's walk around. That's pretty cool. I'm pretty excited about that. So what we should probably do to test it properly, we should probably open up our level editor and make a level that we can actually check everything on, because I just kind of randomly did it. So we'll delete our test level. Let's save the streaming code. Let's go to our level editor. Now it loads nothing. And let's build our level. We'll do a pattern. And maybe we'll put like, this is 2. This is, oh, that's 2, 2. That's fine. And then we'll do another room. Oops. That's fine. Little imperfections are fine. Just want to make sure that we're getting everything. I'll make it so it matches. And this would be 3. And then we'll make this final border wall here. Make it a little longer. Now I want to put this kind of pattern here. Okay, go back. 4 dots. And then we save. And I haven't rigged that yet, but because it's hardwired to a level file, it's hardwired to give us test.ar. Run the game. And okay. Now that's off, isn't it? That's what's supposed to be there. So it looks like we still have a few bugs to work with. But we're close. And it popped up there for some reason. Okay, but we're close. We're close. It seems to work vertically or horizontally better. Cool, so I got to figure out what the bugs are, but we're real close. Excellent. Yes. So yes, what you would do to add different tiles, right? It's simple. Is we would in our level editor, just like I did before, I'd have these different tile types. And okay, so this is, we'll call it tile 2. Let's give it a color. Oh, no. Okay. So we'd build the level, and then we would add the different tile. Right? So there's the tile. Save. So now I've written that tile information. And now the array will have, in those slots, instead of 1 or null, 0, it'd have 2. And then we'll take our tile. We'll move to the level editor. Insert object. Active. We'll paste in the tile. Oh, well, we'll just do it this way. Clone. And then we'll say, make it red. Okay, and that's tilegrass 3. So I want to rename these things. I'm going to call this tile 1, tile 2. Now tilegrass 3 here, this is an interesting one. Tile, what are we going to call it? Group hold. Okay, so here's an issue. And I don't know if it's a bug in Fusion or what, but I'm testing to see if the placer, which is one we're moving along the yellow borders, this object here, is overlapping one of these 2 tiles, right? One of these tiles. These are the only 2 we're going to create. And here's the problem. When the game starts, right, these 2 shouldn't exist, right? So, because they could end up outside the screen. So let's just go ahead and say created start, remove that, right? If you do a comparison, a negative comparison, an object overlapping another object, right? And this second object doesn't exist. There isn't one yet. There's not one created. It won't. This event won't work. It's like a false positive. So what I've done is this object here, group hold, is one that is part of the group, but isn't used, right? We don't destroy it, because you can see here the destruction code is based on this tile type originally, which we're going to have to change that in a second too. So we're going to have to do this, and we're going to have to add a shared group between just these 2 tiles, So we'll call them obstacles. And then we change this to obstacle. And then down here, we would change that to do the obstacles here. The reason we're doing that is because we're creating a new tile type per Jeff's request. But anyways, but this comparison is still with this group, all three objects. If none of these exist, we'll always have this one, so it'll still be able to test true instead of returning a false positive. So that's why that object's there. It's a weird thing. I should probably talk to Eves about it. But getting on to creating those other objects. So up here on our level load, our initial level load, we need to go ahead and do a 2. And if it's 2, then we create the new tile 2, -32 off screen. And then we pop that there. And we should be good. So let's see if it, there's our new tiles. But now we have to add that here. We need to have that additional code put here. So not too hard. We just go like this. And then we create tile 2 relative to placer. And we copy, create tile 2 relative to placer. But we make sure that this is 2 because that's the different tile type. We didn't do that up here. Tile 2. Tile 2 relative to the placer. And then the final one, tile type 2. Create object, tile 2 relative to the placer. And we'll do the detailed view to make sure we got all the code right. It's looking good. Let's run it. Okay, so we leave, we come back, and they're there. Good. So yeah, we're close. And I hope that answers the question about the different tiles. So I got to figure out where I'm off on my alignment with the tile placements. Once we have that done, then I'll post the quote up, and you guys can have fun messing around with that. If you have any suggestions on what to add to it, let me know, and I'll put it in before we post it. But pretty cool. We can now walk around a whole world with little to no resource usage. Limited object count. It's great. How many times have you seen a game in Fusion where, you know, he's made a game with 8,000 objects and it runs like a dog? Maybe something like this is a solution. I don't know. Are there any other questions, guys? Folks. Let's see if YouTube has any questions. The old Fusion 3 release date news. Any news on Fusion 3 will be released via our blog at clickteam.com. It's right on the front page. There will be some Fusion 3 relative news soon. Waiting for some legalities to clear, and then we can announce some positive news concerning Fusion 3. Not a release date. We don't have a release date. Don't have a release date. We're going to do our best to have a beta testable by users, select users, by the end of the year. That's all I can 100% say. It's our goal every day to get Fusion 3 out as fast as possible. What can I tell you besides that? We've got up to 4 people working on it now, and they're killing themselves doing it. So stand by and give us a little patience. Sorry that doesn't answer the question the way you want it, but that's what I can tell you. Cool. Let's see if there's any other questions on Twitch. Doesn't seem so. So I'm going to wrap it up tonight. We're going to watch a Yay Fenny trailer per request of the guys from Yay Fenny. That ought to be fun. And I'll get this polished up and posted for the Reactor members on ClickStore soon. Thanks for watching, guys. Reactor appreciates it. Click Team appreciates it. And as always, let us know what you want, and we'll do our best to make it happen. Thanks for watching again. So it looks like I can't play the Yay Fenny trailer because I don't have it on my hard drive. Sorry, guys. Check out Yay Fenny, Y-E space F-E-N-N-Y on Steam. Fun game. See you guys later.